Good morning, my dear students. Now, welcome to the video number 2. I hope that you've gone through the video number 1. I explained all the preliminary concepts of what the polarization and all that. And the basic point is what? The light waves are what? Transverse in nature. This can be explained only by the phenomenon of what? Polarization. As I told in the video 1 also. Now let us come to the another crystal, that is calcite crystal. It put some imagination is required. This calcite crystal in chemistry it is called as CaCO3. It is a calcium carbonate crystal, calcium carbonate. Or sometimes it is called as ice spar. It is also called as an ice spar. It is called as a ice spar. It is a naturally occurring crystal. Naturally occurring crystal. Here, today morning I told you crystal A and B. This is the instrument. Here there are two crystals are there. Here it is crystal 1 and here the crystal 2. This is tourmaline crystal 1 and this is tourmaline crystal 2. One you can analyze, this is called as an analyzer. This you can call it as a what? Polarizer. If the light is incident in this direction. Suppose the light is incident in this direction, that is immaterial, which is analyzer and polarizer. If the light is allowed to incident on this, this will become polarizer and this will become what? Analyzer. Here inside there is a one, there is crystal is there, is a crystal. Just of course we can't understand unless I hold it near to the eye. Now I should focus it on this. Anyone, that is anyone. Then you go on, rotate it. Then you are getting one particular image you are getting with the bright end. Then go on, give the rotation for it because this is fixed. This is crystal which is towards me. It is fixed and this is an analyzer. Just you go on, rotate it. You will find that in one complete rotation, 2 times the brighter and 2 times the darker you are observing. This is what experiment explains transverse nature of light and all that. Here, calcite crystal. This is a rhombohedral, that is rhombohedral hexagonal structure. Hexagonal structure. Okay. If you look into the diagram in the books, you will not understand this one. I will try to explain it. It is calcium carbonate crystal or sometimes it is called as an ice spar. But in the physics, they will call it as a what? Calcite crystal. In chemistry, it is a calcium carbonate crystal. It is a rhombohedral hexagonal structure and it is a transparent and white. Transparent, it is transparent. And also it is in white. If you go through this internet, you will get many crystals. You can search through the YouTube and you can search it, the calcium carbonate crystal or calcite crystal, you can search it. Now I will draw the structure for this. It is a rhombohedral structure. Always opposite faces are equal. Now this is the phase 1. We can assume that it is in a phase 1. Any structure, of course, it is a simple cubic structure. It has got 6 phases. This is 1, this is 1, this is 2, this is 3, okay, this is 3, and this is what, 4, okay, this is what, 5, and this is what, 6. It has got 6 phases. Similarly, it is of course, it is a simple cubic structure. It is a rhombohedral. Now I am drawing phase 2 and phase 2 and this is the phase 2. This is phase 1, this is for phase 2. I will join it. This is phase 3, students. Similarly, I will join it. This is what phase 4, it is what phase 4 structure. But if you look into this, this is phase 5. It is phase 5 students. Like this. This is phase 5. Similarly, if you look into this crust phase and this is what phase 6 it is. It is what phase 6. It is what only 6 phases are there. Now see the beauty of this. What is the beauty of this is, at this point 3 axes are meeting. One is x, y and what? Z. And angle between any two axes is 109 degree. Some books have given 112 and all that. It is 109 degree. This is also 109 degree. This is also 109 degree, students. Similarly, look into this here. All are equiangles. Here also 3 axes are meeting. 1, 2 and what? 3. This is also 109, 109 and this is also what? 109 degree. This is 109 degree. The point where all the 3 angles, 3 sides are meeting, 3 axes are meeting with equiangles, they are called as this one and this one are called as blunt corner. It is very important. Called as a blunt corner. Here, any line, this is the line passing through it. Don't think that it is a line, it is a direction. It is a direction. This line parallel to this and all that, they are called as a optic axis, because in the next I am using the word repeatedly. I am using the, what is the importance of the optic axis? I will tell you. Optic axis, don't think that it is a direction. It is not a line, it is a direction. Listen carefully. It is not a line, it is a what? Direction. Along this direction, always the velocity of ordinary ray and extraordinary ray is what say. What is ordinary ray and extraordinary ray? I will tell you in the next studies. Remember, what is optics? Optics axis, it is not a line, it is a what? Direction. The properties of the light along this direction, they are what? Different. What is the different? I will tell you later. That is. Okay. This is about what? About the calcite crystal. This calcite crystal, totally it has what? How many faces here? The 6 faces are there, and these 2 points are called as a what? Blunt corner. That is. In the blunt corner, all angles are what? Equal. 109 degree and 109 degree and all that. Next, one more important is principal suction. That is what? Another definition that I have. Principal suction. What is principal suction? Principal suction. Because I am using this word, principal suction. A plane containing an optic axis. A plane containing an optic axis. A plane, you should cut the crystals as that. Like this, you chop it. A plane containing the optic axis and perpendicular to the opposite faces of the crystal. Opposite faces of the crystal is called principal suction or principal plane, they will call it as. What is that? What is principal suction? A plane containing an optic axis, and plane containing an optic axis and perpendicular to the opposite faces, means this face and this face. Just you cut it here. Or else this face and this face, it should come. That is called as what? Principal suction. Here, what is most important is what? Optic axis. Optic axis means it is a line that is what normally it is passing through what? Blunt corner, that is. Here, any of the line, not necessarily this line, this line, this line, this line, all are parallel to what? This line only. All the lines, you see, it is a reference line, you can say. All lines parallel to this. All are what? Optic axis. Many books they have written, it is a single line. It is wrong. That is, it is not a line. It is a direction, that is. Line passes like this, because it is parallel to this. This is parallel to this. And these are called as what? Optic axis. What is the importance of optic axis? I'll tell you later. That is. Next. Double refraction, that is. Polarization can be obtained by what? Double refraction. Double refraction. Here many interesting videos are there in the YouTube. Even already I sent one link also that few days back. Just you can go through it. What is double refraction? Here, what is the beauty of the double refraction is first to explain. Suppose rural college, I am writing RCK, Kanakpura, I am saying. Here, put an ordinary glass plate. Then you look at RCK only. But there are some crystals out there, that is what calcite crystal and all that. Assume that it is a calcite crystal. If I put it this down, it is of course, it should be transparent. When I put a calcite crystal, you are observing two images you are observing. Here, one RCK. Again, it is what? RCK. Two images you are observing. That's why it is called as what? Double refraction. That is. One more thing is that, of course, I'll send this link also, send it. Suppose there is a one dot I'm placing. Take a white sheet paper and put a dot on it. And put on a glass slab, you can put it. Normally, if you look into this, you are observing only one dot through the glass plate. But here, when I put a calcite crystal, you are not observing one dot, you are observing two dots you are observing. Two dots. Two images are formed. Now what I will do is, this is a paper, now this is the calcite crystal. Now you go on rotate this crystal and observe from the top. When you observe from the top and go on rotate it, here one dot remains stationary. This dot remains stationary. It is as usual. Take a paper, put a dot and put your any glass beaker or something, put it, and even if you rotate it also, dot will be not rotate. But this dot is that now it is very interesting factor. It is this dot will be rotates like this. As calcite crystal rotates, this dot is also what rotates. This is a very interesting phenomenon you are observing. You never get this kind of property with any ordinary glass or something. You are getting particularly with what? Calcite crystal, that is. Calcite crystal, that is. Here two images are formed, image 1 and image 2. Image 1 is a stationary, image 2 is what? Rotates, that is. This is the interesting phenomena you are observing. Kindly go through that video also, then very interesting things. Usually you can understand the things now. Now let us come to the double refraction. Students, look at this. This is an unpolarized source. Even sunlight is an unpolarized source. It has got vibrations in all the directions, like this directions, in this plane, in this plane, in this plane. All the vibrations are present. Now, this is the calcite crystal. It is a rhombohedral structure, and I told you. This opposite angles are equal. It is 109, it is 109. And this is 71 degree. This is also what? 71 degree. And this is the property of the crystal. That is. Now, I have drawn one normal. I have drawn that is. This is the normal drawn. This is the normal. This is the incident light. Now that is this is the incident ray, and this is the what? Refracted ray. It is called as calcite crystal. Calcite crystal. Here you are obtaining the two rays are obtained. Here you see, this is one ray. This is the one ray. And this is what? Another ray. This is another ray. Two refracted rays, and hence two images are observed. This angle is smaller, certainly it is R1. This is angle of incidence. And this angle is R2. I'll tell you why R2 is more and all that I'll tell you next. Here, in this, the red line I draw now, where the vibrations are like this. Vibrations are like this. It is in the plane of propagation of the what? Light. This ray I will call it as a what? E ray. E ray means extraordinary ray. Extraordinary. Extraordinary. Not extraordinary. It is called as an extraordinary. In shortcut, I will call it as a what? O ray I will call it as. Next one, here, vibrations are perpendicular to the plane of the board. It is like this. Here, for this, in this plane, for this, it is like this. These are called O ray, or it is called as an ordinary ray, that is. Why it is called ordinary? I will tell you this. Here, the ordinary ray always it obeys the laws of refraction. You know the laws of refraction, you know that. Whenever the light travels from one medium to another medium, that is, from rarer to denser medium, it bends what? It is away from the normal. When it travels from the what? Denser to, when light travels from rarer to denser medium, it bends towards the normal. When it travels from denser to rarer, it is away from the what? Normal. And also we know that, of course, 1 minute, I'll complete it. Ordinary ray. Ordinary ray. We know that N equal to C by V. You recall this equation? What is the meaning of this is? Here, for a given medium, whether light travels like this, light travels like this, light travels like this, the velocity is V is what? Same. V is what? Same. This is the what? Ordinary. It's applicable for the what? Laws of what? Refraction. Here, how many images are formed here? Two images are formed. One is ordinary and another one is what? Extraordinary. Here, O ray, it is always the laws of refraction. First point I will write. O ray obeys the laws of refraction. Laws of refraction. What is that laws of refraction? That means that whether light travels in this direction, in this direction, in this direction, for a given medium, the speed of light is what? Remains same only. That is ordinary ray. And how the vibrations are? Vibrations are perpendicular to the what? Plane of the paper or plane of the what? Board here. Second point, student. E ray does not, that is important, does not obey the laws of refraction. Laws of refraction. This is the second point. Third point, I told you that is optic axis. I told you, no? It is a line. It is a line. It is a line along which velocity for ordinary ray equal to velocity for extraordinary ray. This is important point. It is a line. That is, it is a line means which line here? Optic axis. Optic. Along the optic axis. It is not a line, it is a direction where velocity for the ordinary is equal to the velocity for the what? Extraordinary. Here, this is very important while understanding the Huygens wave theory and all that. There is, again, I am using this point, you remember it. Once again, along the optic axis, velocity is same for the ordinary and extraordinary ray and all. These are the important points. And optical axis, I told you, it is an imaginary line, or it is just simply it represents the direction. Next, you might ask question, is there any varieties of crystals are there? Yes, that is double refracting crystals. Here, double refracting crystals are two types. Double refracting crystal. It has got two types. One is positive crystal and another one is negative crystal. What is positive crystal and what is negative crystal? I'll tell you this. Here, positive crystal means, remember, velocity of ordinary ray is greater than velocity of extraordinary ray. This is the positive crystal. Whatever you are studying, exactly opposite here it is. And we know that N equal to C by V. How N and V are related? Inversely related. If velocity is more, refractive index is less. And refractive index for the extraordinary and refractive index of ordinary, both are different. You see, velocity is more, then N should be what? Less. Here, N of ordinary is less than what? N of extraordinary array. This is important. Exactly opposite what you are getting in case of what? Negative crystal. Here, which is more here? Velocity for ordinary is more than the velocity for extra. It is exactly opposite. Velocity of extraordinary is more than velocity of what? Ordinary. Similarly, bring it to this equation. If velocity is more, N is what? Less. So that N of extraordinary is less than N of what? Ordinary. Here, example is quartz. Example is quartz. Quartz. And another example, zinc oxide. This all comes under this. Next, here the examples are tourmaline crystal, tourmaline, ruby crystal, like that. Tourmaline, ruby, emerald, emerald. I think many fellows, they are wearing this emerald, ruby and all that, depending upon their astrologer suggestions. That is what. Of course, there is a different story, that is. This is the what regarding the what? Double refraction. Sometimes they may ask you the question, write a note on a double refraction. It is very easy, just like a Ramayana Mahabharata. If you once understand, nothing in it. Let us consider a calcite crystal, and already have written this angle is 109, and this is what? This becomes what? 180 degree and all that. Here it is an unpolarized source. When they are allowed to incident on the crystal, the rays are, the two refracted rays are what? Obtained. Here this angle is R1 and this is angle of refraction, and this is what? Also angle of refraction, where R2 is what? More than what? R1. This ray is called an extraordinary. In extraordinary, the plane of vibrations are in the plane of the board or in the plane of the paper. And here in ordinary, the vibrations are perpendicular to the plane of the board. Second point. Third point, you have to write, it is the one imagined line. That line is called an optic axis, along which velocity for the ordinary is equal to the velocity for the extraordinary ray. Don't forget that point. Next one is, there are different double refracting crystals are classified into two types. One is positive crystal and another one is negative crystal. In positive crystal, remember, velocity for the ordinary is more than the velocity of extraordinary ray. I know this equation. If velocity is more, refractive index is less, so that refractive index of ordinary is less than the refractive index of extraordinary ray. Remember, any one point easily you can write that is in opposite sense. You have to write for the negative crystal. Examples for the negative crystals are tourmaline, ruby, emerald. It is emerald, EME, and this is quartz and what? Zinc oxide. Like this, many crystals are there. Of course, I have written only two examples I have written. This is regarding the double refracting crystal. And one more is there, the construction of the Nicol prism and all that. Construction of the Nicol prism. That I will explain in due course. I will explain it. Okay. So it is very somewhat it is difficult even to understand how the people are constructing the Nicol prism. Nicol is the name of the scientist who constructed this prism by using the calcite crystal. Some modifications he made here in its physical structure. Okay. Even I took nearly about more than 7-8 hours I took here in order to understand this, how Nicol is constructing the Nicol prism from the calcite crystal. Is just to honor him by using the word Nicol, that is prism, that is. Let us come to this. This is the calcite crystal. Just now I told it. It is a calcite crystal. I told you these are called as in what? Blunt corners. It is called as a blunt corner. Why it is called blunt corners? What is the importance of this? Here, this angle between any two axes is what? 109 degree. This is one blunt corner. This is another blunt corner. This also, the angle between any two axes is what? 109 degree. Students, just I am taking the out of this. Just only one part of it I am taking. One face I am taking. I am representing in this form. I think you can able to understand this. I told you that is always in the raw matter structure, the opposite angles are what? Equal. It is 71, 71, 109 degree and 109 degree and all that. This crystal, in order to increase the field of view, field of view means observations. To increase the field of view, he is cutting the crystal in such a way that this crystal is cut like this. Through an angle 68 degree, that is what? 68 degree. He cut it. Earlier, this is what? 109 degree. Now, 1 minute here, of course. This is 71 degree now, but now it becomes 68 degree. It is decreased from 71 degree to what? 68 degree. It is reduced. How much degree is reduced here? 3 degree. At the same time, this angle should be increased by 3 degree. This will become 112 degree, students. I think you can able to understand this. This part is there now. He removed this part here. Similarly, this part is also opposite faces, this face and this face, he cut like this. Here, how much it is? 71 degrees there, no? Now, it is now. It is earlier, it is 71 degree. Now, this will become 68 degree. This is 71 degree. What? Red dots. This is 71 degree. It is decreased by how much? 3 degree. It is what? Decreased. Now, this angle, now it becomes 3 degree. Earlier it is 109 degree. This will increase by 3 degree. It is 112 degree. Now the question is, you would ask question, why he cut only by 3 degree? Why he reduced only by 3 degree? I'll tell you in the next, that is what I'll tell you. Within no time, I will tell you. Why it's taken only 3 degree? Why not 5 degree? Why not what? 7 degree? And no. This is what the construction of the what? Nicol prism is. Of course, it involves, that is one blunt corner is also what? Involved and all that. Next, I will draw the, what is the purpose of the Nicol prism? Just to get the what? Polarized light. To get the polarized light. To analyze, to polarize, and also to analyze, again, he is using the what? Nicol prism is using. This Nicol, he constructed the prism such a way that from the calcite crystal, he cut the what? Faces. In such a way that he reduced 71 degree to what? 68 degree. You see, this is 71 degree, this is 68 degree. As a result, this angle 109 degrees is there now. It is increased by how much? 3 degree. It is what? Increased and all that. Okay, 1 minute. Okay, now about the Nicol prism. This is the modifications made in the what? Calcite crystal. He said that it is 68 degree and what? 112 degree. I told you guys. Earlier it was 71 degree. 71 degree. He cut into what? Reduced to what? 3 degree. It is 68 degree. Certainly 109 degree and is increased to what? 112 degree. He will cut it like this. Cut the portion like this. Then you are getting the two parts you are obtaining. This line, how should we know? You should pass through the blunt corners. You should pass through the blunt corners. Here you see why I had drawn the dotted line. Earlier, this value is how much it is? 109 degree, students. And this is 68 degree. Then certainly this value is more. It is what? 71 degree. Yes. This is what? 71 degree. No, it's not required. Okay. This is the unpolarized light. This is unpolarized light. Unpolarized source. Now it is incident on it. It is nothing but calcite crystal only, some modification. Here I have drawn the normal to it. This is the normal. This angle between incident ray and this normal is called as an what? Angle of incidence. Now that is two rays are obtained like this, and another ray will be travels like this, and this ray, you see, travels like this, and then here it is normal and travels like this. This ray I will call it as a what? It is called as extraordinary ray. I will call it as an extraordinary. Of course, one point I not explained. This crystal is what? Cut into what? Two parts diagonally. This also what? Diagonal means it is also what? One blunt corner. This is another blunt corner. And cut it. Then you paste it using a Canada balsam. That is Canada balsam. It is a gum. Just like a quick fix, Fevicol is there, no? Like that. Canada balsam is the one material. He is pasting these two. Again, you are getting what? This kind of situations you are getting. When ordinary light, when it is allowed to incident on it, now two rays are obtained. As you know that one is extraordinary and another one is a ordinary. Here you see vibrations are like this. Vibrations are in the plane of the board. In the plane of the board. This is extraordinary. In extraordinary, the vibrations are perpendicular to the plane of the board. That is what. This is called as water. You know that this ray, it will undergo total internal reflection. That is, I think, recall it, what you said in the few seconds and all that. Total internal reflection. Suppose the light will be incident on it. Then this light, it is what? Reflected back into the same medium. That is. For this, to get the total internal reflection, you know that angle of incidence should be greater than the what? critical angle. What is critical angle? The critical angle, you know that for this particular angle of incidence, the refracted ray just it makes, and how much it is? This is refracted ray, this is the incident ray, and this angle, it is what? This is I equal to what? See, here angle of refraction equal to what? 90 degree. Suppose if it is 37 degree, now refracted ray is like this, 37 degree. I will increase more than 37 degree. It will no longer, it will travel like this. It will travel where? Within the same medium it travels. That is what total internal reflection and all that. Okay. Here, you are separating the extraordinary and ordinary completely. You are separating that. Is it not polarized light you are getting? Is it not you are filtering the waves? Because this contains only one kind of vibrations which are perpendicular to what? Plane of the board. Here, vibrations are in this board and all that. Here you see, N of C, C stands for Canada balsam, equal to 1.55. Next, N of ordinary equal to 1.658. N of extraordinary equal to 1.486. We should add it, that's why there is no other solution. This is refractive index of Canada balsam. Canada balsam. This is for ordinary ray. This is for extraordinary ray and all that. Now I will answer you why Nicol is cut only to what? 60. Why he reduced the angle from 71 degree to 68 degree, that is. And this light, it will undergo what? Total internal reflection. What is the condition for total reflection? The angle of incidence should be greater than the what? Critical angle. Here you see, and light must travel from denser medium to rarer medium. That is the condition for the total reflection. Light must travel from denser to rarer medium. You see. Now I will combine these two. Here NO equal to 1.658. NC equal to 1.55. Here NO is greater than what? NC. This is called as denser. Why it is denser? Its value is more. This is called as rarer optical medium. If I use the equation critical angle sin C equal to refractive index of rarer medium means critical angle. This is a refractive index of denser medium, nothing but O. This you substitute here. Here NC equal to 1.55. This you substitute, it is 1.658. You substitute all these values, then C equal to sine inverse of this value. 0.9348 equal to 0.9348, 0.934. This value is very close to what? 68 degree westwards. I think we can able to understand this one. Here you see the critical angle is how much it is? 68 degree. That's why if this light, incident light, it should be greater than the what? 68 degree. Then the light will undergo what? It suffers from the total internal reflection. One more point I forgotten here. This is R1. This is what? R2. That's angle of refraction for the R1 is what? Lesser than the R2. R1 is less for which ray? O ray. And R2 is more for the what? Extraordinary ray. Why should be more and all this different history is there, but it is not required from the point of examination and all that. Here, what is the use of Nicol prism? The Nicol prism is used, is an efficient device for the production of the polarized light and also for the detection of the polarized light. I think you are using polarimeter experiment you are doing in B.Sc2. Where in the polarimeter experiment it is what involved with the Nicol prism and all that. What is the purpose of the Nicol prism? The Nicol prism is used as a polarizer and also what? Analyzer. What is polarizer? It converts unpolarized light into what? Polarized light. What is polarized light? It consisting of vibrations in only one restricted plane. In one particular kind of what? Vibrations are there. Either in this plane or in this plane or in this plane or else what? In this plane and all that. Here he selected the Canada balsam. Why he selected the Canada balsam particularly is this refractive index lies between ordinary and extraordinary. You see, it is less than this, but it is more than this. And nothing but any gum material, that is, you can say Fevicol, Fevistick, something, that is what. Here I have read there is one advertisement that in the tube they are using for the what, to paste the plastic. You can use for any material except heartbroken, that is the except heartbroken. Of course, we cannot use it. Here you see NO equal to 1.658, NC equal to what? 1.55. Why I am using only these two is, in order to get the total interreflection, light must travel from denser to what? Rarer medium. This is denser medium. This is what? Rarer medium. And using the definition of the critical angle, sin C equal to refractive index of rarer. Rarer means what? NC. Divided by refractive index of denser. Denser nothing but what? NO. 1.55 divided by 1.658. It is very close to what? 0.699348. Then C equal to sin inverse of this. This comes under what? 68-degree angle. That's why he considered the Nicol prism in this fashion. Thank you, and all students. Next video, I am going to solve some problems related to what? Related to what is that? N equal to tan theta p, Brewster's law and all. That I am going to solve it. Thank you, one and all.